In this video, we will look into the writing part and we begin with the question 16 that is about continuity and limits. We have a problem here. Suppose that a state's income tax code states that the tax liability on X dirhams of taxable income is given over here. This is a piecewise equation. You can see there is one piece, two pieces, and three pieces. The first equation and the limits are given here. The condition is X must be less than or equal to 0. Whereas for the condition of the second equation here is X is greater than 0 or less than 10,000. And lastly, it is less than or equal to X is greater than or equal to 10,000. So these are the three conditions and these are the three equations here. Now we need to determine the constant C. The C value is unknown, which makes it continuous for all values of X. So now this must be all continuous. If this is continuous, then we must have the limits equal for all these conditions. Now, let me just quickly tell you about continuity. Now, imagine I have a graph like this. If I take any point, if this point is continuous, then the previous value and the right side value will match. They will be at the same point, isn't it? The y value over here will be exactly the same for both the points. It might vary by 0.00. Basically, when you equate that, only then it is continuous. Now, if we have, say, discontinuity like this, and this point do not match, the value over here and here, left and right do not match. So now, how we can solve this is, because since there is only one unknown, one variable, that is, one constant value C, I'll just consider this equation for sure. C plus 0.21x. But now, how can I solve this? When you consider this 10,000 value, you need to also consider the above equation. What is that? 0.14x. Now, they both are not equal, but if you take the limits at x, what is the x value? Of 10,000. See, it's 10,000. And over here, limit of this first equation, also x is at 10,000. This one, and over here, this one. Over here, I've written big brackets because there are 2 points, but you can just write the small brackets, it's fine. So these both are equal. These both equations aren't equal, but because they have told it is continuous, the function must be continuous for all x values, right? Then the limit of this and this will be equal. Which is the corresponding limit? If it's 10,000, 10,000. If you're taking equation 1 and 2, you should take limit x value of 0 and 0. Now let's solve this up. So all you do is substitute the limit over here. Let me just write it out over here, 0.14. What is the x value? It's 10,000 multiplied with 10,000. That is equal to, here C is unknown, but C is a constant. They are mentioned C is a constant. So what is the limit? Example, limit of x, say, tends to any value, okay, 0. Whereas you have over here 3. What will be the limit? It's going to be just 3 itself. Why? This constant value remains as it is. So in this case here, the same thing happens because it's a constant C. Doesn't matter what is the limit. When you apply the limit to the constant value, it remains C itself. Plus, but here there is x term. So you substitute the x term, right? So 0.21, this is point. And now instead of x, what do you multiply it with? 10,000. So now you can just simplify this. Since it's the writing part, I'm not going to use calculators here. Let's just directly do it. It's 0.14. When you multiply it with 10,000, it'll be 1,400. So 2 decimal places. So just take 2 zeros and 2 zeros remain. And over here also it is C plus, it'll be 21,000. Sorry, 2,100 or 2,100. That's it. Now you need to find the C value. So what do you do is take this to the other side. It's going to be 1,400 minus 2,100. That will be C, or C value is negative 700. So that's the C value, the constant value. So this is what they are asked us to solve. Now that's it. C is negative 700. I hope you know the limits, you know the basics of it. If you are still having confusion with how this and all works, you need to go to the lesson explanation and be thorough with it. Now here I'll just stick to these questions only. Here they have asked you to give rationale why such a function should be continuous. This is very important, understanding why. Now, there are various ways. I'll tell you what this means, but before that, let's look over here. If the salaries are less than zero, so x is less than zero, so now we can ignore this, it's zero tax, obviously. Now, if the salaries range from, say, 0 to 10,000, then your tax range is over here given over here. Then, as your salary income is increased over here to, say, 10,000 or 10,000 or more, then this is the slab rate. Now, imagine if they're not continuous. You earn 10,000, you will be taxed over here. But what if this is very high and then you are earning just little bit more than 10,000? Let us say 10,500 dirhams. So then if this was not continuous, that means this can be very high. Then there is an unevenness, right? This is going to be very high tax just for 10,500. That shouldn't be the case. If you're earning 10,500, it must be very, very close to this. So that is the reason they are all continuous. So you just increase a little bit of income, it's not going to be a problem. As you increase more and more, that's going to vary a lot. Only as the salary increases by a lot. Maybe if it's 50,000, yes, this is going to change a lot. But if it's from 10 to 11,000, it's not going to change. See, over here they are telling a small change in income should not result in a big change in tax. Of course, because if you're just earning, say, from 10,000 to 11,000, you won't have a big change in the tax. That's the understanding behind it. Now let's solve another problem here. It is similar to what we have done just a while ago, but here you have two constants, two unknown constants. So we can't start with these two. See, we can't use these two over here. Why? Because there are two unknowns. If we take limits of this equal to this, your a and b unknown not gonna help us, right? So what we do is we'll take the equation 1 and equation 2. Let me write limit as x. What is the x value here? It's 0. Okay, now when I'm doing this problem, I just realized the inequalities, the signs must be given here. The last problem I did not mention this. I'm sorry for that. Now I'll mention it properly. Let me leave it for as x for a while. This is equal to limit as x tends to, again, it's, see, if we are taking 0 here, it must match, it's 0 itself. Now what is the limit here? A plus 0.12x. Now here, can you see it's less than or equal to? So let's take a negative sign. That means it's showing from the left side. Now here, it's again, x is, see, x is greater than 0. So we can take a plus sign, means indicating it's from the more than that value. So this is the difference, because here x is less than or equal to 0. So negative sign, here it's positive because it's greater than 0. Now then, how would we solve this? Limit of 0, it's a constant, so 0 only remains. What about this? We have a plus 0.12x. You substitute 0 here, it will be limit of a. See, this limit is for a plus limit of this one. A is a constant, so it's a. But over here, what happens is, since we have x, we have to multiply x as 0, and we will get 0 is equal to a. This is again 0 plus 0. So basically a is 0. That's it. That's the first part. Now we will do the second part for to solve for b, because now we found a. We know it's 0 here. Now we can easily solve it. I'll just clear this all up and let us do these two equations. But we know here the value of a is 0. Okay. But when I'm writing the limit equation, I'm going to take this directly as a itself, a plus 0.12x. What is the x value? It's not 0, it's 20,000. See, 20 and 20, we are going to use x value of 20,000 for both. It's 20,000. That will be equal to limit x value tends to, again, it's 20,000. And over here we have b plus 0.16, again, times x minus 20,000. So I'll use the big brackets here just for indication. And now where does it become plus and minus? Over here, the limit. Now since x is less than or equal to 20,000, over here it's minus, and over here it's greater than, so it's plus. If it was equal to, you can just leave it as x is 20,000 itself. Don't need to put any signs. This sign indicate it's more than 20,000 or greater than or equal to. This minus indicates it's less than or equal to. Now I know this a value is 0. So limit of a that is 0 is 0. Plus what about this limit? It's going to be 0.12 multiplied with 20,000. So that will be equal to right side. Limit of b, since it's a constant, it's b itself, plus 0.16 multiplied by 20,000 minus 20,000. So that's going to be 0 again. Now this is the thing. Anyways. So here I have 12 multiplied by 2, it's going to be 24, and 1, 2, it's going to be 2400 or 2400. Here we will have b as it is, plus this is going to be 20,000 minus 20,000, which is a 0 multiplied by, I'll just write it over here in detail. It's going to be 0, and now this is again going to be 0. B plus 0. Here we have 2400. So A value was 0 and B value is 2400. This is the answer, and A value was 0. So those are the two answers. We need to do the steps in detail. All this, if you write, you're going to get full marks in writing. So here you can see they have written the first one, A is 0, B is 2400, but just don't write the answer. There's no way you're going to get marks. This is for the second B value, but we did the similar way for A value. You need to write everything in detail. In this problem here, we have to continue from example 4.8. In the example 4.8, we basically solve the A value from this table. Now, these are the given values. You have the equations, and the remaining equations you need to solve by yourself. In the sense, it's just very simple. Your tax liability is given as 30%, which is say 0.3. In percent, 30% is 0.3 x minus this value a. So the next one will be 0.35 x minus b, and so on. Now what is the limit? Ranges over here is 67,700, where x, see, now the continuity is the same. X is less than or equal to, over here it is 141,250. Now, most likely this will be given to you in the question. Okay, now because it's continuing from 4.8, it's a little bit confusing. But otherwise, as you have seen the other problems, this will directly be given, and the constants also will be given in the question, and it will be pretty straightforward. Now, how do you solve this problem? Now, you need to use the last one over here, this one, and then this one, and then you can easily solve for A. And A is done. We have to deal with only B and C here. Now I'll write the equations for these. It's pretty simple. 0.35x minus b. So I'll just write it over here. We already have 0.3x minus a, which is over here given. Next one is 0.35x minus b, and lastly is 0.386 minus c. And these are the ranges over here given. I'm not going to write it again over here. But now, how do we solve it? A value is known, so let us take this and this. But what will be the x value limit? It will be 141 and 141 to solve for B, because A value is known. Now let me substitute over here with the limits. Let me write it over here. Limit as x tends to 141,250. This is left side because it will be less than. X is less than this value, and that's the first equation, that is 0.3x minus a. This must be equal to the limit at the right side, that is again 141,250, and this is from the right side because x will be greater than this value, and it is 0.35 x minus b. Now all you do is substitute the value of a over here. It is 5685. Now what happens here is it will be 0.3 multiplied by this x value, 141,250. That's the first part, minus a value. As we know, it's a constant value. Limit doesn't affect the constant values. It will be just 5685. 5685. And the right side here, the similar thing, it will be 0.35 multiplied with 141,250 minus b. See, this is the only constant. Now you can type this all entirely in the calculator and solve. Since the numbers are not whole numbers, we will use calculator to solve here. Now here, what I'll do is I will try to solve part by part because it's writing. So the first section here, 0.3 times 141 times 250, 141,250. Here you get it as 42,375. This will be subtracted from 5685. And here, the right side, all you do is, here, it's just 3 5 times, and when you press ST you get the value in decimal. It is 49,437.5. Now you might be thinking, can we directly put this in the calculator and get the answer? Absolutely yes. I'm sure you will get full marks even if you put directly this equation in the calculator and b as the variable x and shift and solve. You will get the answer. You can use that directly, but since it's writing, I'm just using steps. Now here, what happens is this is negative b. So we have to take this minus b to the other side and all the numbers to the right side. But before that, we can just simplify this, right? 42375 minus 5685. The answer is over here 36,690. So I'll directly take this negative b to the other side, becomes positive. And here we have 49,437.5. And this answer over here, 42 is bigger, so it's 36 is positive. But when it moves to the other side, it becomes 36,690. When you solve these two numbers, 42,000 so on and 5,600, when you subtract it, you're going to get 36,690 positive. But we move that to the other side of inequality and this negative b to the other side. So negative b will become positive b. Now all you do is, I'll just subtract it over here just to save time of typing. And the answer, it should not be negative because I use the other way around. The answer is 12,747.5. So B value is 12,747.5. That's the B. Now similarly, once you have found the B value, you can equate these two equations. And just like what we have done over here, just substituting this to phi x, and this x value changes to 307,050. And then over your right side, the equation changes. C will be the unknown variable, and just continue the same method. You will get the answers. So here you can see the value for B is solved. You can see the answers are over here. And let us just double check our answers. Did we get it all right? We got 12,747.5. Yes, that's absolutely correct. This is the B value. Now, similarly, when you solve for the C, whatever I did a while ago, see, the same thing, same method is very important. Only the equations change. You will get another answer, but that will be the C value. So here the C value, do it by yourself and then check the answer. It's 23,801.3. Again, we have to use the same example over here. Show that Tx is continuous for x is 6,000. Now, where is x equals to 6,000? That's over here and over here. There are two inequalities which vary, right? So we'll take these two equations and solve quickly. If it's continuous, when we solve these both, the x values must match. What I mean is, let me do limit x. I'm not going to write both together. I'm going to individually do it. Limit x tends to 6,000 from the negative side. It's 0.10x. Okay. I'll write it anyways equal to, but then I'll solve it individually. Must be equal to the limit as x tends to 6,000 from the right side. That's plus side. Okay. What is the equation? The equation is 0.15x minus 300. So these two must be equal. So now let me do it separately over your left side and then let's see whether it's equal to the right side. What I do is I just substitute this over here. 0.1 multiplied by 6,000. Here what happens? It's 0.15 multiplied by 6,000 minus, see, this is the first part done, minus 300. Wherever x was there, I just put 6,000. That's it. Now here it's pretty simple. 1 0 is gone. It'll be 600. But now what about this? 65, it is gonna be 15 times 5, 75, 85, 90. So 90 and 1, it'll be 900. So this is 900 minus 300. And let's see, yes, 900 minus 300 is 600, and over here also is 600. Yes, these two limits of x tends to 600 from the negative side of this given function t of x is equal to the limit of x when it tends to 6000 from the positive side t of x. If this is true, then what, it is continuous. So yes, we can say 100% it is continuous. That is what happens. You are getting 6000 and 6000 in both the cases. So yes, it is continuous at 6000. Again, similar problems. It's just that we have a over here you can see there are different types of problem. There are about 3 types of problem. The first type is done. That was about tax problems, and now we have again similar continuity. It's the same concept. We will do this now, and then we have another type altogether in different page number which we'll solve. So now these, just like the first type, what we need to do is here see what is the x value. It's all 0, so it's easy. We need to find a and b. Because this is all known and this is unknown, we will use these two and then we will use these two. So how do we solve it? Left side, the limit as x tends to 0, it's less than, so it's minus 2 sine x by x. Please remember to put this minus sign. I tend to forget it. I many times may have forgotten in the video as well. I can't recall now, but you please don't forget to put this. You have to put, if it's less than, it's minus. If it's equal to, just leave it as limit. That's fine. Now here limit as x tends to 0, but what is the value? It's a. That's it. Now, since it's writing, you can't use calculator, or if you just use calculator, we'll get the limits directly, but now we will solve it. 2 is a constant, so it's done, but the limit will only be for this part. X tends to 0 from the left side, sine x by x, then equal to, what is the limit of a? Any constant will be the constant itself, so it's a itself. Now if you recall, do you remember the formula limit of x tends to 0? I'll write over here, there's a formula as it's 0 for sine x by x. The formula is given as 1. Please remember, you can do it in your calculator as well. We have done it before in the lesson explanations. Just remember, this is a formula. Now, since it's writing, you need to write this somewhere and apply over here. It'll be 2 times. This entire thing is 1. That is equal to 8. So, 2 is a. Done. But now we are not done completely, because we have one more thing over here, right? So we need to do these 2 equations as well. Similarly, just like what we have done over here, we will do for the other 2. Now just remember, a value is 2. I'll clear this off and write it over here itself. So here now limit as x tends to 0. What is the, it's a, but we know a is 2. We'll write it in a while. Now x tends to 0 from the positive side because x is greater than 0, and here we have b cosine x. Now this is 2, so the constant remains, it's directly 2. But what about this? B limit as it is. Now because it's a constant, the limit will only be applied to wherever x is there, right? So x tends to 0 from the positive side, cosine x. Here what happens is basically substitute this 0 instead of x, because it's a polynomial, right? There's no divided by x. It's not going to be undefined. These are all straightforward substitutions. So when you apply 0 to x, cos 0, cos 0 is 1, sine 0 is 0, cos 0 is 1. You can check it in the calculator. So here you just remember it is going to be 1, so 2 is equal to b. In fact, both the values a and b were 2 itself, so both are 2. So that's how we solve it. Please write these steps. They are very, very important. So both the values are 2. A and b must be equal to if f of x is continuous. Say if this is continuous, what we did is valid. The method which we did, this is important. And then you get the answers of the constants. Let's try one more Again, it's similar to what we have done just now. I would highly encourage you to stop watching this video now. Solve it by yourself. Pause it. Pause the video, do it by yourself, and then check for my explanation. I hope you have tried solving it by yourselves. Here we have entirely given is only this. There is a constant A, constant B. So we will use 1 and 2, and then we will use 2 and 3. So limit as x tends to 0, less than means minus a e power x plus 1 must be equal. Since there are two terms, I just put a bracket. Limit as x tends to 0 from the positive side. Why positive side? Because over here x is greater than 0. And what is it? Over here it is sine inverse of x by 2. That's the thing. And now what you do is you basically substitute the values. How do you substitute this? Direct substitution. There is no denominators over here. So direct substitution would be, first of all, let's say over here there is a variable a that will remain. And when you substitute e to the power 0, anything power 0 is how much? It's 1. You can try any number to the power 0, or you can write e and 0, it will be 1. So let me substitute this first and then let me solve it. And what happens with the constant? Again, over here, there's no x, so 1 remains as it is. This side, it is sine inverse of x is 0 by 2. Now let's solve it up. Now what is sine inverse of 0? Sine inverse of 0 is 1, but let me just double check. My bad. Sine inverse of 0 is 0. But anyways, let's see how to do it. Shift and sine. You'll get sine inverse 0 by 2. And over here, close a bracket, you get 0. Now I feel so silly. I don't know. It just vanished from my mind, I guess, a while ago. Sine inverse is over here 0. Then over here, what happens? E to the power 0 is 1, so a remains plus 1. Now this a to the other side becomes a equals minus 1. So the first answer is a is minus 1. Now we find this. In fact, we don't need to join these at all because they are completely different. So sine inverse remains here. All we do is the left side changes. So what I'm going to do is, instead of rewriting everything, the right side is same. So I'm just going to change this side. Okay. So that is me being very lazy not to rewrite anything. Oh, my limit is gone. Let me get it back. Okay, it's back. Now here what I do is the limit. Oh, I need to make it 2. That changes. Okay, the values change, but anyways, most of the other things remain. Here limit is 2 and 2. Now since I've written this at the right side, remember x is less than or equal to this is minus, this is greater than, it's plus. What is this? It's x squared minus x and plus b. So now we substitute this 2 instead of x, it'll be 2 squared minus 2 plus b. And here also instead of x we put 2, so it'll be sine inverse of 1. It'll be half pi or something. Yeah, half pi or pi I was thinking. Anyways, sine 2 by 2 is 1. Sine inverse of 1 is half pi. That is basically 90 degrees. Now let's write it in terms of half pi itself. What happens here? It's 2 squared is 4 minus 2. It will be again 2 plus b. 2 squared is 4 minus 2 is 2 plus b. And I'll take this to the other side. b is half pi minus 2. Let's leave it like this because generally if you leave it like this in terms of pi, it's more than enough. Let's see the solutions as well. What was the first answer we got? Yeah, I believe we got minus 1 itself. Yeah, I can't exactly remember, but the just now's answer is yes, half pi minus 2. So this is how we solve these problems. And now there are few more problems. Please do try it by yourselves. It's the same thing. Use calculator when you substitute. See tan inverse. Use calculator, natural logarithm. Use a calculator to verify your answers. And you can see the method is also over here. Try these by yourselves and check for the answers. And over here. Okay, we will go to the last type of problem here, 67th. These 67 to 71, there are, I think so, two different types of problems. Let's look into them. Suppose that the length of a small animal t days after birth is given over here. Length over here, the height as a function of time, 300 by 1 plus 9 of 0.8 power t mm. What is the length of the animal at birth? What is the eventual length of animal? That is the length as the time goes infinity. That's the maximum length of the animal. So now, many animals can be modeled by this equation. They take a lot of data from like various different many animals of the same species, and then they come up with these equations. These are more reliable. They give you, I mean, not more reliable. Sorry, they are reliable enough. They give you accurate enough data. So now, let's first understand what is happening. So they have an equation over here, and this will give you the height or the length of the animal at any time t. So at birth, what is the time? Time is 0 at birth. Generally this will be 0, but let's just substitute and solve. It must be 0. So now what is the time t at birth? 0. All you do is substitute over here, take the limit as t tends to 0. This will be 0 and we need to solve it. I'll solve it in a minute. But what about the other thing? T infinity means, imagine it, you don't know what's the time length, lifespan. It may be 10 years, 20 years, anything, right? So infinity means the maximum length it can reach, the maximum. So then we take limit, t is infinity, and we get it. Now let's solve one by one. First one, limit as x tends to 0 for this function 301 plus 9 of 0.8 times t. Let's just substitute this as let's just substitute directly t over here as 0. It will be 300 divided by 1 plus, see, whatever you substitute here, what's going to happen? It's going to be 0. So that's power 1. 0.8 power 0 is 1. So it's 1 plus 9. So you have 300 by 10, and this cancels, it's 30. Okay, I apologize. I told something wrong. I told it's going to be 0. My bad. At birth, animals have some sort of length. What am I thinking? It's pretty late at the night, so that's why my brain is getting frozen, I guess. So this is the length mm. So when babies are born, there is some weight, minimum weight. On average, it's 30 mm for this particular animal. Now, what if it's the maximum? X is infinity. So the same thing, you just take t as infinity and solve it up. Here, time t, but this limit, okay, this is not x, I'm sorry, I just realized it. It's t. Now you substitute t as infinity here, it's 300, 1 plus, okay, I've not done the substitution over here. It's better you do one more step, just that t becomes 0. See, I'll show it over here. It's 9, 0.8 power infinity. Now, what's going to happen when 0.8 is infinity? Now, let's use our calculators and check here. Let's take a whole number. Let's take a number which is bigger than 1. Say 9 power, I'll take 5. See, it's increasing. Let me take 10. It's a huge number. How about we'll take 99? It's a huge number. It's going towards infinity, right? But now the same thing, I'll make it as 0.9. Can you see it's getting into a smaller number? See, here, always remember, when you have anything less than 1, say 0.1, when you take this, it's such a small number, it's 0.00001, it's almost equivalent to 0, okay? Now we have here 8. When you're taking a huge power, that is infinity is a huge number, you will get a bigger and bigger as the power increases, you get a minute number. So when it's infinity, it's 0. So you can see it's almost 0. If you put more values, I think so, yeah, it's 0. So here what happens is, this is going to be 300 divided by 1 plus 9 times 0. So it is 300 by 1, because this is 0, it's 300 mm. So the maximum length that will reach is 300 mm. The minimum is 30 mm. So these are the two answers. Please write this and this. That's it. Now here they have not written anything which is not desirable. Like, I mean, you can directly get the answer from here, but still it's better to write the steps. Okay. A similar question again, just the equations are changed. Now I would highly encourage you to do it by yourselves. I will just show you here. The steps would be limit as x tends to 0 and limit as x tends, it's not x, it's time, right? Time tends to infinity, here also time. And what is the equation? It is 100 divided by 2 plus 3 times 0.4t, and here it is 100 divided by 2 plus 3 times 0.4t. You substitute here 100 divided by 2 plus 3 or 0.4, this power is 0. But here what happens? It is 100 divided by 2 plus 3 into 0.4 infinity. And when it's 0, it's 1. So it will be 100 divided by 2 plus 3 only, because this is 1. And it's 100 by 5, 20 times 220. And over here we have, it is 100 divided by 2 plus, what happens here? It's 3 infinity 0.4, so it's 0. 3 multiplied by 0 here. So it's basically 100 by 2, that is 50. Now it's in terms of mm. That's it. That's how we solve these problems. 20 and 50 is the answer. So maximum length is 50, minimum is 20. Okay, this is different. Let's solve this one. Suppose an object with an initial velocity v naught, v naught is 0 feet per second, and a constant mass m, slugs is accelerated by a constant force f pounds for t seconds. According to Newton's law of motion, the object speed will be velocity n given as ft divided by m. See, this is Newton's formula. Velocity of n, that is n is for Newton, is force times time. Force times, in this sense, multiplied. Force multiplied by time divided by mass. And then Albert Einstein did this theory of relativity, and he got this new formula, which is more reliable because this was wrong. You might have studied in physics. What happens? What is the flaw in this? The flaw is the velocity is supposed to be infinite. As the mass becomes 0, I mean, when you take the time infinite over here, infinity, what happens? Mass is becoming almost equal to 0, right? So this velocity also becomes infinite, which is really not the case. What is the maximum velocity we can ever reach according to the laws of physics? It is the speed of light, isn't it? So Albert Einstein added the speed of light here. Now let's see Albert Einstein's. It's a little bit more complicated, where c is obviously the speed of light divided by the square root of mass square c square plus f square t square. Okay, now what do we do? All we do is take the limits at infinity. Time t is infinity. It's pretty straightforward. So we have to take the limit of this function only. This is velocity given by Newton. Time tends to infinity. And what is it? Function of time divided by m. And here when we substitute this as infinity, what happens? If infinity is on the numerator, everything is infinity, right? That's the answer for velocity for Newton, which is wrong. Why? Because we cannot go past speed of light. Let me just tell you, this is very interesting concept. Speed of light is about 300 million meters per second, or it's 300,000 kilometers per second. This is a very enormous speed because no one could define this before. Obviously, Newton was in a very many centuries before Einstein, so he didn't have a lot of technology, but he still found a lot of things. But Einstein rectified a lot of things as well. Now he found out from the speed of light is the maximum we can travel. But in our real world, we have just reached about, I think so, 2,500 kilometers per second. This is the maximum speed we have ever achieved. in the whole world. Now the speed of light is 300,000 kilometers, and we have barely touched 2,500. I think so. It's less than 2,500. So this is the difference you can see. So there's a huge, huge, huge difference. Okay, it's very not comparable. But anyways, coming back to the question here, velocity of E, that is answer and velocity. Now same thing, we do limit as x tends to infinity, and here what happens is basically, okay, first let me write it. FCT divided by square root m square c square plus f square t square. Now put infinity wherever. But before that, since we have t over here and t, what do we do is we have to remove this out and try to cancel or simplify as much as possible. Don't directly put infinity. That would be wrong substitution. Why? Because there's up and down here, right? We have to simplify this term. So t, let it be fct. But down, you remove this t outside, but there is no t, so you divide, multiply and divide over here, and then you will have two common t's. So it'll be t square out t. When you take outside the square root, how much is it? It's just t. So basically, in such cases, you remove this outside, it's just t square root m square c square. Was there any t square here? Only t square was over here, which we removed, it became t. So there was nothing here, so you basically divided by t square plus f square only. Why here f square only? Because you can see this t square is removed outside and it becomes t. Here you divide it. That's a simple algebra over there. And now this cancels off with this, so you're remaining with fc divided by square root m square c square by t square plus f square, and the limit is what? As x tends to infinity. Now what is, now this t becomes infinity square. 1 by infinity is equal to what? 1 divided by huge number is equal to 0. Limit of whenever we have limit 1 by x, when it's tending to infinity, it's 0. So this entire thing, mc square, everything becomes 0. Now we are remaining with fc by square root f square, isn't it? Now this cancels. You have fc by ff cancels c. That is the speed of light. So according to Albert Einstein's velocity over here equation, the maximum velocity you can ever attain is the speed of light. This is the answer. I just googled it. I don't know how this was sticking to my mind. It is really 40,000 kilometers per hour. That is the maximum speed humans have ever achieved. I think so. It's an Apollo mission. I just googled this, but this is in hours. But when you convert it to kilometers per second, this is going to shock you. It's just 11.11 kilometer per second. So the speed of light is 300,000, whereas in the universe we have, in Earth we have just reached 11.11. You can see the difference, it's 11.11 and the speed of light is 300,000, but this is the maximum we can ever attain. But it's kind of very, very such a huge number to reach. Anyways, we will move on to the next question here, and you can see this is the answer. For the first one was infinite, yes, and second one is just C. Here we have a question about medicine. After an injection, the concentration of the medicine in the muscle varies according to the function of time. So the concentration once after you have been injected varies according to the time, and it's given by this function over here. Find the limit f of t for both as t is 0 and infinity. So we should do the limit of 0 and infinite and interpret both limits in terms of concentration of the drug. Sorry. Now let's solve it up. Limit as x tends to, sorry, it's not x, it's again time t0 for this given function, minus 0.02t minus e to the power minus 0.42t. Now since it's 0, I can just directly substitute. Otherwise, if it's infinity, what do you do is you have to take it down because it's minus, right? I'll write that in a while. Let's just solve this for now. So all you do is substitute t as 0. So it's going to be e. Everything becomes 0 here. minus, again over here, e to the power 0. So e to the power 0 is 1 minus 1. So answer is 0. That's it. So that is when the time is 0. What about the limit as time tends to infinity for this particular equation? E minus 0.02t minus e to the power minus 0.42t. So what you basically have to do is, since there's a negative sign, let's write the limit as it is. I'm not going to substitute now infinity. I will take this down. E1 by e to the power positive 0.02t minus 1 by e to the power 0.42t. Now let's substitute the limits. It'll be 1 divided by e to the power 0.02 multiplied by infinity minus 1 divided by e to the power 0.42 multiplied by infinity. Okay, that's so far fine. Now, what is e to the power infinity? Now, e to the power infinity, since e value is bigger than 1, it's 2.72 and so on, right? You will get infinity here. 0.2 multiplied by infinity is infinity itself, and this is going to be infinity. So it's going to be 1 divided by infinity minus 1 by infinity. So 1 divided by infinity limit, it'll be 0 minus 0. So answer is 0. So both the cases, the answer is 0 itself. So that's the answer, guys. Okay, this makes sense because drug will require some time to. Now it's about, you've been injected. Okay, when you have an injection, at the time zero itself, you're not going to feel the effect. You might feel after some time, because since we're doing time zero, at that particular time zero, you won't have any effect of the concentration of the drug, right? So therefore, the muscles will be fine. It'll be just like normal. So there's no effect over here. And also, if you're taking t as infinity, it's going to be a long time. Obviously, the drug's effects will be gone off, But if you have certain, say over here, t is 1 hour or something, then you will have some value. But not in this case, because we are doing at 0, limit 0 and infinity. Obviously, the muscles will not have enough time to reach, or it will be wearing off. The effects will be gone. We move to the last question in this topic 16. That's question 71. Ignoring air resistance, the maximum height reached by a rocket launched with the initial velocity v0 is given over here, where r is the radius of the earth. In this exercise, we interpret this as a function of v velocity, initial velocity. Explain why the domain of this function must be restricted to v0 is greater than or equal to 0. So here obviously v0 is initial velocity and it must be bigger than 0 because you're propelling a rocket, right? So depends on the direction. Rocket, it's flying up, so it's being launched with initial velocity to go upwards. So velocity must be positive. It can't be negative. It won't go down, So that's the reason. That's the explanation. Let me just look into the answer because I don't know how exactly they have written the answer. Yeah, that's it. Because the formula makes sense if the rocket is launched upwards. That's the only thing over here. Let's see the other parts. There is an additional restriction. Find the positive value of VE such that H is undefined. So we are find when H is undefined. Sketch the possible graph of H for V0 is less than V but greater than 0, and discuss the significance of the vertical asymptote at VE, that is V is the escape velocity. Okay, so basically we need to deal with when H is undefined, when this down term becomes 0. Okay, then this is undefined, right? When is any number undefined? When you have 1 divided by 0, this is undefined form, isn't it? So now here the numerator doesn't matter, the denominator when it's 0, right? So that is the vertical asymptote as well. So let's solve this one by one. Now we don't have to take any limits here, nothing limits. So the first one I just told you, since it's going upwards, the domain will be positive. What about this H? So let's just equate this entire term, 19.6 R minus V0 square. Okay, this will be equal to what? 0. Let's solve it up. Now what is the R? R is the radius of the earth. So that is like 6,000 plus. I'm really not sure. Yeah, it's 6,000. Oh, it's given in meters. In kilometers, it's about 6,370. I was thinking it's 6,378 this 1,000 kilometers. Or over here, since it's given in meter per second, let's write it as it is. R equals 6,378,000. So that's the thing. Sorry for that. Now here, let me just substitute the values. Here, let's take this V naught to the other side. It'll be 19.6 multiplied by R is 6378000 equals V naught square. And let's take the square root on both the sides. And let's see what is the V naught value. Sorry, this one is the VE, because when H is undefined, it's VE. So it's the escape velocity. Let's use a calculators first. So all you do is put this in the calculator directly and you get this as 11,180. So basically this is the maximum, see VE is the escape velocity, right? Now what happens is when you launch a rocket, because of gravity, it's going to fall down eventually. But if you launch it with more than 11,180.73 kilometers per meters per second, then it's not going to fall back. So what happens is basically it's gonna go up and it's gonna go into the orbit. It's not it'll not be affected by the gravity as long as it's more than the escape velocity. So that's the concept behind it. So we find the escape velocity because they have already told h must be undefined. So this denominator just equated to 0 and solve it up. So that's the answer. So you can see they've just rounded off. It's over here 11,180. That's the answer. So that would be the end, and the graph over here. So if you graph this up, you can graph it over here. When you reach 11,000, that's going to go up. That's the vertical asymptote. So what happens here? That'll be the maximum. So you can't reach more than that. So basically, that is the end of question 16. There were plenty types of problem. Make sure you try to write each and every question and practice by yourselves.